This is a long question with 12 marks from February-March 22, paper 21, about spring and pressure. A spring is extended by a force. The variation with extension x of the force F is shown in this graph. A. State the name of the law that relates the force and extension of the spring shown in that graph. This is the Hooke's law. When a spring obeys Hooke's law for a given graph forces versus extension, there are two considerations. One, the graph should show a straight line, and two, the line should start from the origin, meaning that when no force is applied, there is no extension. B. Determine the spring constant in newtons per meter of the spring. The spring constant, represented by the letter K, is the gradient of the line, which is rise over run. To determine the gradient, let's select 5 centimeters of extension and see on the line the corresponding force, which is 7 newtons. So because the spring constant is in newton per meter, so this 5 centimeters is equal to 0.05 meters. Back to the expression, so our rise is 7 newtons over the run is 0.05 meter. So the result is 140 Newton meter. The next question is asking the strain energy or the elastic potential energy in the spring when the extension is 4 centimeters. The strain energy, which is the same as the elastic potential energy in a graph, can be calculated by finding the area under the line. At 4 centimeters of extension corresponds to a force of 5.6 newtons. So the elastic potential energy is the area under this line, which is a triangle. So the area of a triangle is the base times height divided by 2. So the spring elastic energy is the area of a right triangle. So doing the substitutions, the base is 0.04 meter, or 4 times 10 to the minus 2 meter, times the corresponding force, which is 5.6 Newton, divided by 2. So the spring elastic energy is equal to 0.112 joules. With the two significant figures is 0.11 joules. Question C. One end of the spring is attached to a fixed point. A cylinder that is submerged in a liquid is now suspended from the other end of the spring, as shown in this picture. So it's giving the spring extension 4 centimeters. The cross-sectional area of the cylinder is 1.2 times 10 to the negative 3 square meter. The cylinder weight is 6.2 newtons. This is a liquid around the cylinder, and the cylinder length is 5.8 centimeters. To summarize all this information, I have here a table for you with the extension, the length, the cross-sectional area, and the weight of the cylinder. Because the question states the cylinder is in equilibrium, so the sum of forces up is equal to the sum of forces down. We have the weight as a force down. Forces up, we have the force at the spring and the upthrust force, because the cylinder is submerged in a liquid. So here we have Fs plus F up is equal Fg. Rearrange this equation for the upthrust force. Now we have Fg minus Fs. The value of Fg was given is 6.2, but we don't have the value of the spring when the extension is 4 centimeters. Then we need to go to the graph. For 0.4 meter or 4 centimeters, the corresponding value for the force is 5.6 newtons. Now we are back where we left, and now we have 6.2 minus 5.6. So the upthrust force is 0.6 newton. So we have shown this statement is correct. The next question is asking to calculate the difference in pressure between the bottom face and the top face of the cylinder. So here is the cylinder, this is the pressure at the top of the cylinder, and this is the pressure at the bottom of the cylinder. So the difference in pressure between the bottom and the top surfaces is the upthrust force. So to calculate the pressure due to the upthrust force, we can use the formula for pressure. So the upthrust force that we already calculate is 0.6 newton, and this area is provided in the question, is 1.2 times 10 to negative 3 square meter. So the result is 500 Pascal. The next question is asking to calculate the density of the liquid. So the pressure can be calculated by using this formula as well. So rearrange it for the density. So we have a pressure over height. So the pressure of this on the cylinder is 500 Pascal. And the difference in pressure, the net pressure, is 500 Pascal. And the length here is the height of the cylinder, 0.058 meter, which gives us 879 kilograms per cubic meter. Question D. The liquid in C is replaced by another liquid of greater density. State the effect, if any, of this change on the upthrust force acting on the cylinder and the extension of the spring. To relate the upthrust force with the density, we have this formula. So pressure is the density times G times height. So if the density increases, then pressure increases. To relate the extension with the density, we need to bring this formula of pressure, which is the upthrust force over area. If pressure increases, then upthrust force also increases, which brings us to this equation right here, which relates the cylinder in equilibrium. So here, if the upthrust force increases, then the force in the spring decreases. So to relate the force of the spring with the extension, we are going to bring here Hooke's law. So the extension is the force on the spring divided by the constant. The spring constant, since it's constant, is not going to affect this. So if the force of the spring decreases, then the extension also decreases.